The Distributed Application Runtime, or Dapr, with Mark Fussell.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your humble host. Make sure to check out www.azuredevops.show for past episodes and show notes. And just one quick announcement. In January, I'm teaching another class of my .NET DevOps Bootcamp. Sign up now to reserve your spot. But let's get right into the show. Mark Fussell is here with me, and he works on the Azure Compute team and is the product manager for the new Dapr framework, or the Distributed Application Runtime. You can find him on Twitter at twitter.com/mfussell, MFUSSELL. And we're going to be talking about Dapr. You can go to dapr.io, github.com/dapr/Dapr, and Dapr is DAPR. And we'll share some more resources throughout the show. But Mark, welcome. How are you, sir?
Thank you for having me here, Jeffrey. I'm super excited here to talk about this new open source project and what it can do for developers out there.
Well, absolutely. I'm interested in learning about it. But, the Azure team is just exploding. Can you give us a sense for what your role is and kind of what your journey has been and how you landed there?
Yeah. Let's talk about my journey. So, I've been a pretty passionate advocate of building microservices-based applications for the last 10 years. So about 10 years ago, I actually started a project building a platform called Azure Service Fabric, which is the platform inside Azure where we build all of our large-scale services. So things like Azure Cosmos DB, Azure SQL DB, Event Hubs, a lot of the other databases inside there, such as Postgres and MySQL, as well as things outside of that as well, a lot of things in Office 365. And in that journey, we've seen a lot where people transform their world from building those classic three-tier applications, where they had the back-end database, the middle tier, and then the front end. And it transformed it into a service where you had to break apart the application into this microservices approach, where you had smaller pieces of code, each one of them independently built by different teams, versioned and rolled out to make it more agile, because you had to keep the service always running. You had to provide new features on a regular basis. So that's where a lot of my passion has lied over the last 10 years. And then this Dapr is simply an evolution of that, of how we bring that to a broader audience and make it easy for developers to build these sort of microservices applications.
So you were the guy behind Azure Service Fabric. Now, I know it's a big team.
Yes. So it was in 2009. We were looking towards the future and kind of going, in fact, it started because the first version of it was built inside Azure databases, or Azure SQL Relational Database, as it was called then. Now it's just called Azure Database. Yeah. And from then, we slowly convinced other teams to build on top of it, including what was then called Link and now called Skype for Business. And from there, we went in Stream Analytics and Azure Analytics and many other services. And now it powers all the large services inside Azure. But generally, that journey, of course, along that journey as well, we've also seen other platforms who build distributed apps. So we see Kubernetes as well, and the rise of Kubernetes, and that's really the kind of instrumental one that you see in the industry today. Broadly across the industry, you see Kubernetes deployed as a platform in which you can build distributed applications that also sometimes they're called cloud native applications like this.
Okay. Now you mentioned when you start talking about microservices, where people had to break it up into different parts. Before we go into how to do it, why are people saying, "Oh, I'd like to break it up"? Let's reflect on the common pain that you see out there.
Yes. Well, the common pain has generally been a transition to, there's a design architecture that's totally valid and we should totally use, where you want to build these sort of enterprise applications where you have sort of a single back-end database and some middle tier software. And that's a perfectly fine, great design approach. But as people transferred to building services, and the key here was your services, where they would maybe start small, maybe there would be a few machines and then start to scale as their growth. What they couldn't afford to do constantly is re-architecture. And the classic three-tier design was usually a re-architecture. You'd have to add more databases. You'd have to add more middle-tier software. You'd have to think about adding more of the front end. And you had to babysit each one of these machines. As you went to a service, you merely wanted this scale to become natural. So you could go from 3 machines to 5 machines. And the platform take care of, oh, no, I'll take care of placing it on this machine over here because you don't have to think about where the most optimal place to run this piece of code is. And it also came down to agility. There was a need to break apart these applications so I could ship so say you're building a shopping cart, a purchase order service, and you built a shopping cart application, and you've built an inventory application, and you've built a purchase order application. You want different teams to be able to push out those changes at different times. So before, what happened is that teams sat down, they all built and tested this thing over like several months. And then Microsoft used to do this. There used to be this big team, would compile all this code together, would ship it as one giant executable every year, and then everyone have a celebration. Well, no, in a service, it's like every hour, you're pushing out changes to the inventory service or the shopping cart service. And so that move to the service forced the breaking apart of applications, agility, scale, in order for you to get your customers to be able to have the experience they needed as an always-on service.
Okay. And then if a certain part of it needs to change at a different frequency than others, there's that flexibility.
Correct. That's right. So if, for example, you say you have an inventory service and you need to push out more changes to your inventory, a team can choose to build that new inventory service, push out that single change into their application, into their platform, do a rolling upgrade where it would pull down the new binaries, put them onto a machine, make sure it started up the version 2 of it. So versioning is very important in this whole pipeline. So you go from version 1 to version 2 in a very controlled way. And also realize that sometimes you push out a version that's wrong and need to roll back to a previous version. So the ability to roll out and roll back seamlessly. And as you go through that, you're doing health checks to make sure that the version 2 comes up correctly, that new client connections come to version 2. You may even have this concept of policy-based routing where 20% of the traffic goes to version 2 and 80% goes to version 1. So you're testing it all out for a while. And then when you're happy, you keep going and rolling this thing out. So agility around this. And also importantly, teams can also write those services in very different ways. One team could choose to write it in, with one developer framework in one language, another team could use another. And it's not that you want everyone crazy doing whatever they want, but it provides the best flexibility to use the right tool for the right type of service that you want. So those were the sort of driving changes. And so in the industry, you pretty much see now this accepted paradigm as we've gone through all of these eras. Now, the 80s was the era of sort of like the mainframe, and the 90s was the era of sort of client server. And then in 2000s, we went into this sort of SOAP messaging REST era. The web, yes. And now we're in the sort of era of microservices and building large services as we continue to break apart and scale these things.
Yeah. And this decade is all of, I don't want your software. I just want to log in to the software.
Yes,
I don't want to install your software.
Yes. Yeah, that's the other thing as well. Yes, exactly. I just want, here's the service there and it's always running. And if I want to use it from my phone or my tablet or whatever, I can just use it. And that's the key now. Very much, APIs available on the web that you can stitch to get to and build these services.
So Dapr, when did the first thought begin that, Microsoft needs to provide a framework for this? How did that all start?
Well, actually, that's a fantastic question. So in many ways, the seed of this has come from the journey as we've gone through seeing customers build these large-scale services. And there's sort of like three layers when you start to look at the infrastructure you need. You sort of, at a very base layer, you need this hosting platform that allows you to start containers or processes, do process activation, failure, discovery, leader election, and all of the complexities of that. And platforms like Service Fabric and Kubernetes and Docker Swarm provide those capabilities. But then we found that on top of that, you needed to abstract away developers from the experience of building the application, and you wanted to build a concept of an application model. So there actually is also related to this, which people should check out, another open source project that we released at the same time called the Open Application Model, OAM, or OAM for short, that also describes a way of putting your microservices application together, how one service relates to another, and how you can do policy between those services. As I described, 20% of the traffic going to one and another. But what we then realized was that we were asking all these developers in the world, you have to transition now to become a distributed systems developer. You had to build a service that knew how to talk from one to another. It knew how to hold state, create stateful long-running services. You had to do event-based messaging between them all. And developers were now spending more and more of their time writing sort of this low-level distributed systems sort of primitives and architectures and not on their business logic. And that took away and distracted them from getting their job done effectively. So we started to realize what we needed to do was provide this programming model building blocks that allowed you to take the best characteristics of building a distributed application and be able to plug that into the programming language or the framework of your choice. So let me give you an example. It's very common that when you build one of these microservices applications, you want to call from the shopping cart, say, service, to the inventory service or the purchase order service. And so you want to be able to do a call between those two. Now, you want to be able to take advantage of the platform helping you do those calls. And quite often, a lot of the platforms enable you to do things like a DNS call between the two services, and you can do it that way. But it's usually that's fixed to that particular platform. So what Dapr comes along and says is, we'll provide you this consistent way of being able to call from one service to another with a URL format where you say, I want to call onto service, my purchase order service. Here's the name of the method I want to call, and here's the parameters. And it will do all the hard work of discovering where that service is, calling onto the methods and doing that call for you. And now when I write that code, it's independent of the platform. So I can run that code on, say Kubernetes, or I can run it on my edge service, or say IoT Edge I'm running on on edge devices, or I can run it on Docker Swarm. And now and so Dapr provides you this building block called service invocation that does all that hard work for you. And now as a developer, you can simply just write very consistent URL type mechanisms to be able to call between these services. Does that make sense?
It does. So when I think of the way that two running processes can call each other, they can call synchronously, and the options are gRPC or web service, or putting an asynchronous message on Azure Queue, or a file system. Or are there certain use cases that Dapr is more focused on and less focused on as well?
Correct. Yeah. So you touched on actually another types of building blocks there. So the whole goal here now is that you as a developer, we don't want you to do all of the hard distributed systems problems. We want you just to be able to plug in these building blocks. So when you bring in Dapr to your application, what it does is, the important thing is it runs as this sidecar process. And this little sidecar process sits next to your code. So you can do simple local host calls to the sidecar process for the functionality that you want. So for example, you just talked about how I want to call from, say I want to do a publish and subscribe event between my service and all the other ones in the system. As well as doing direct invocation, I want to call from the shopping cart service to the purchase order service. I can also do publish and subscribe. So for example, I can call this localhost endpoint and say, I want to subscribe to topics A, B, and C. And then another service can say, I just want to do publish to topics A, B, D. And the Dapr sidecars running against all your little, each one of your individual services in the system will coordinate and communicate, and we'll do a publish and subscribe system amongst them all. So the key element is this, is that Dapr runs as a sidecar process next to your code that you can do local host calls to provide distributed systems functionality, such as direct method calls, publish and subscribe, saving state, and also doing diagnostics. Does that make sense?
Yeah, I think so. Localhost, does that assume that it's running on a VM versus maybe Azure function?
No. All it means is that when I launch my application, so for example, say I launch an application that consists of a shopping cart application and a purchase order application. Mm-hmm. Each one of those has a Dapr sidecar process running next to it all. So the shopping cart application will have its Dapr side process, and the inventory application will have its one. And then you're able to now, in your code, be able to say, I just want to call onto a piece of functionality. So I can do, for example, publish and subscribe between those services without me having to understand how to use any particular publish and subscribe service as part of the platform. So the key here is that this is pluggable, and I can plug in different pub sub services of my choice. So to make this more concrete, I could choose to call between these two services using the standard URL format, but under the covers, the publish and subscribe mechanism is using, say, Event Grid, or it's using Service Bus, or it's even plugging in Amazon Simple Notification Service or Google's pub subsystem. So the key now is that the code becomes portable, so that when I write this and use these URL formats, I can choose to have this code that runs on one platform, say in AWS, and it can also run on Azure, and it can run on Edge. And it makes it, and be able to plug in these different pub subsystems underneath it all. So now I have a consistency for wherever I run my things, and I can provide capabilities to the code that I'm writing without me having to write all that code myself.
Okay. In a normal situation for a synchronous web service call between A and B, A would have to have a configuration setting for the address of B. Does this change that?
Well, it just merely says that you just refer to that application. If I want to call from A to B, I just simply say call service B and call its method, and Dapr will take care of discovering wherever that is. Because, for example, you may have a 50 machines cluster running,
right,
and it could be on machine 10, and the next moment it could be on machine 25. So, the fact that it moves between machines is transparent to you, and Dapr will take care of the routing of that message for you, simply because you just refer to the name of the application that you want to call.
Okay.
I would also, let me give you another example of where Dapr fits in very well. Maybe, are you familiar with Azure Functions?
Oh, yeah.
Yeah. So in Azure Functions, they have this great trigger mechanism. So you have bindings and triggers, where you have the concept of a trigger that comes in and runs your code. And it allows you to activate a piece of code based upon an event that, for example, has landed on a Kafka queue or an Event Hub queue. So Dapr is exactly the same concept, where you can run this Dapr sidecar, and then you can plug in any external resource that you want to trigger your code. And so that could be a Kafka queue, it could be Event Hubs, it could be Event Grid, it could be Cosmos DB database, it could be an Azure file system that triggers all of this. And now what this enables you to do is to have event-driven architectures where your code gets triggered based upon some external message that arrives to a particular endpoint. So, for example, you may have the new order endpoint inside my microservice, my ordering application service. And when a message arrives on an Event Hub queue, that will trigger the new order endpoint method and cause me to pick up the order from Event Hub and process it. And what this enables us to do is you can plug this into any framework. So although Functions has this capability for triggering from external queue, from external things, ASP.NET Core doesn't have that. So the ASP.NET Core developers have gone, well, wouldn't we love to be able to trigger this sort of stuff? Well, all you have to do now is launch Dapr as a little sidecar next to your process. And we've done this integration piece that allows you to have ASP.NET Core applications be triggered from external events, and you can drive those now with an event-driven architecture, just like you can with Functions. And that general approach of being able to plug this functionality into any framework and any language, you can provide it to Python and Django developers. You can provide it to Spring Boot developers inside Java or ASP.NET Core developers. Now brings us triggering functionality from a distributed application to all developers wherever they come from.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Let's get through some announcements. The .NET DevOps Bootcamp training course, another date was announced for the course. We had a fantastic class in October, and next class will be January 16th and 17th in Austin, Texas. And this class is based on my latest book published through A Press, which you've heard about, .NET DevOps for Azure. And if you'd like to learn more about how to set up that high throughput DevOps environment for your team, get the copy of the book, .NET DevOps for Azure, anywhere tech books are sold. Also, as many of you know, I'm available for hire. I love helping teams get better. And one of our very popular services is a 30-point DevOps inspection covering everything from your version control structure through builds, testing, quality control steps, to deployments, and even production monitoring. And between now and Christmas, we are giving away a few of these for free. Now, the price for this is $5,000, and we provide a comprehensive report with concrete recommendations and a plan for resolving any gaps we see. So send me an email at jeffrey@clear-measure.com. That's JEFFREY. And once the promotion schedule is full, that's it. We're full. But if you're a regular subscriber, then you have a good chance of getting one of these promotional inspections. So send me an email, and until that promotion schedule is full, we'll give you a free 30-point DevOps inspection that we normally charge $5,000 for as a special promotion between now and Christmas. So I'll be looking out for those emails. And now back to the show. So it sounds like correct me if I'm wrong, the developer experience to be able to consume an event or a call is just to write a method of C#, and then Dapr invokes it. Correct.
Yes, that's it. So you literally write your method the way it gets invoked now is that you have an HTTP or a gRPC endpoint hosted in your code, and Dapr will call back onto that for you. So in many ways, your code gets hosted in a hosting environment, such as a web, some form of web host around that, and then Dapr just calls that. And so then you can do this sort of triggering based mechanism around these things. And you can the key is it's very simple to put to include that in any existing type of code you have. So we've for example, we've seen people take existing Java code and just be able to include Dapr as a sidecar and now have new capabilities around it all. So it's not like you have to rewrite your application. That's the key. You can just start to bring each one of these building blocks that Dapr provides into your existing application, like triggering your application and state management as well. In fact, I think state management is a very interesting one as well. One thing that we see a lot when you build microservices are these long-running stateful services, where you want to have a service that when it fails over and it recovers, it remembers the state of the variables it was running. Mm-hmm. And Dapr provides another endpoint where you say, call the state API and give it a key value pair, and it will take that data and store it into any store of your choice. You can store it into Redis or Cosmos DB or DynamoDB or Google storage, and that's the kind of the plugin model. But my code of just storing key value pairs doesn't change. I just say, call the Dapr state endpoint, here's a key, here's a value, go off and save it for me. And now you can have a service that when it fails and starts up on another machine and recovers, it loads this key value store of data and recovers all that state and becomes a long-running stateful service, for example.
That sounds like the Saga pattern.
Yes, it is in some ways. Well, the Saga pattern, yes, exactly. The Saga pattern is state recovery and yes.
I'm
exactly.
thinking of two other ones that started as open source projects, In-Service Bus and Mass Transit, that had some similar patterns there.
Yes.
But I'm thinking, as you're describing this, I know you're thinking about really massive, high-scale applications, but I'm thinking of some simple use cases too that everybody has if they have a web application. And a lot of times they need to take a transaction that just happened and ship it over to a reporting database or to a data warehouse where it needs to be denormalized. And writing to that database, if they put it right behind the web call, is going to slow down the web traffic because it's doing more processing than it's necessary. And so they just pop it on a queue, and then a little ETL window service or web job runs watching that queue. But is it true that with this, they could use the Dapr sidecar process, and then the code to do the little ETL transform to write to the data warehouse could actually be in the web application project instead of having to sprout a specific web job to do that?
Yes. I mean, exactly. Well, I mean, in that particular case, you're pushing something out onto a queue for later processing. That approach probably still remains valid, but in that case, you would, there's two ways that Dapr would help here. One is, in that approach, you might have to pull in a particular binary for that particular type of queue that you're going to write to.
Okay.
And I have to include that. Code inside my application. I'm going to bind to say it's Event Hub. I have to pull in the Event Hub client library. I have to bind to that. I'll have to write all my code to that. And now what that means is that if I wanted to make that code portable to a different environment, I've bound a particular Event Hub, and I'd have to change that code and write it in a different way. So one thing that Dapr does is it just provides you with a common way of saying, I just want to write to a queue, and here's my data. And then you can plug in and dynamically change whether it was an Event Hub or Kafka or whatever you wanted to write to. So that's one thing it will do. And that pluggability makes it so that you can not have to change your code and then dynamically change where the queue you write it to. But in your other case of just offloading some of the state where I wanted it to do later processing, you could also take advantage of Dapr's statefulness, where it would just write it to a backend data store for you, and then some other process could pick that up and read it later. So it could make it a long-running stateful service as well. So correct, yes. Okay.
Now, so it sounds like Dapr just uses any other storage provider you configure, whether it be Azure Queue or SQL Database, I guess anything?
Yes, yeah. So exactly. So there are 6 building blocks that we provided as part of Dapr to begin with. One was how to do service invocation, talking between two services, which is a bit like a reverse proxy and how you do that. Another one was how we do publish and subscribe between services for event-driven. Then there was a triggering mechanism. Then there was state, of how you recover state, and that again can be a choice of any stores that you want to hold key value data pairs inside there. Then we have pluggable distributed diagnostics, so you can actually see the calls between all your services using open telemetry as to format around those things. And then finally, we provide this built-in concept of actors and this actor pattern. I don't know if you're more familiar with the actor pattern in terms of how an actor represents code and state, but we see that those actors are very common when you build distributed applications today, because they represent code and data in this unique sort of stateful little object that you can create millions of them everywhere. And we've seen in the past that the actor pattern has been very well used, for example, in Internet of Things, IoT scenarios, where you can have an actor that represents a device, for example, and then you can have, say, 1,000 thermostats or 1,000 data logging applications, and each one of them is represented by an actor, which is a stateful, long-running object with methods on it that you can call. So those are the sort of 6 key building blocks that we provide out of the box that you can plug into each one of these, any distributed system, any application framework, I should say. So our goal is to integrate this with ASP.NET Core and integrate this into functions and integrate this into even sort of backend frameworks like Blazor. We're thinking about how that would go there as well.
Got it. So what's the level of maturity of the project now, and what should people start using it for now versus what scenarios might they just keep an eye on it?
Yes. So we just released a project about 5 weeks ago now. So
okay.
And so it's still fairly early. We've been making sure that we test out a lot of customer scenarios around these things. Some interesting scenarios that we've been building so far is some of those things around IoT scenarios. And we've had quite a few people reach out to us as well, how that they can use Dapr in some of their existing projects. So we've been talking to, for example, one of the customers that we showed in a demo that Mark Fussell did at Ignite talk was a customer called Geek Plus, and they had warehouse robots, and these robots go around the warehouse and they deliver different inventory goods between different shelves inside the warehouse. And their application was very monolithic. It was very hard to maintain. And we've started to break their existing Java application apart and create it into a more microservices architecture by using Dapr to provide these capabilities between their code. So that's just an example of how it's being used in an existing app. We also worked closely with an infrastructure company called Willow, and their scenario is that they look at the railway infrastructure, and they look at the quality of the railway lines, and they actually have physical machines on trains that look at the state of the railway track, and from that they can do computation of the data and data crunching. And so we've been building an application with them as well. So that's a good example of where it's running on premise. It doesn't have to be in the cloud, and that's the key. I can write an application that would run inside Azure, but if I want to take it and run it on my physical hardware, I don't have to rewrite the code anymore. It's because Dapr will run across many different platforms. It'll run across Kubernetes in the cloud. It'll run across Kubernetes on the edge, for example. And so this portability makes it very compelling depending on where you write your code. So that's the way we find ourselves today, but it's very early yet. What we're trying to do is we're trying to get more and more customer case studies on top of this, whether it's gaming or medical. And our goal is to try to get to a stable, V1 release of Dapr for next year. Once we've got, plenty of large scale use cases to be able to harden the building blocks and to make sure that, we're ready for this to be, used not only in Azure services, but also taken as an open source project that you can use inside your applications. Okay.
Is there a target for when you hope to make a big announcement, big splash? Is it going to be an announcement at Build next year? What is the thinking?
Well, I'm sure there'll be an announcement at Build next year, but I don't really know what that looks like just yet. So yes, I'd love there to be a big splash at Build, but I can't really say at this point in time. So much of this depends upon, what we've actually seen. Actually, it's been quite phenomenal what's happened over the last 4 weeks, because we've released Dapr and we've had an explosion of GitHub stars on our repo. Lots and lots of people have come up to us and said, this exactly solves the problem I was trying to do. And I see now that when I was in my narrow little world of my framework, it provided a couple of capabilities. And when I was in this narrow language, it provided these capabilities. But I see Microsoft now, they've provided this platform that I can plug in anywhere, and it fits in exactly with the scenarios I want to do. And what's also been interesting is the community's been coming and plugging in their own components to this. So, for example, we've had community contributions to build different backing stores. Someone plugged in a pub sub server called Nats, which allows you to do pub sub between services. Another community person plugged in Google Firestore as a backing store. And so, this community momentum of plugging in their different stores on top of this API, coupled with the scenarios that people keep telling us about how it fits so well and how they were constrained before, has been quite exciting, actually. So that's the goal. And the goal very much, we have to be very clear here. Our goal at Microsoft is that we want to engage the community very, very, very deeply with open source projects, make sure that there is a community built around Dapr, get the community's thoughts and proposals into all of this. We have every 2 weeks, we have a community call. We held one actually of Tuesday this week. It was very interesting. We did a demo of how the distributed tracing works. And then we talked about a proposal for the circuit breaker functionality that we have. And we're going to have a circuit breaker that, if you call from one service to another and it fails, how often do you do the retries? What does the circuit breaker look like? And, we just wanted to put this out there and get feedback for that capability. And, we had some great feedback from people about what their ideas and thoughts were. So, hopefully, fantastic. Yes, driving that ideas and driving real customer cases will get us to a point where we can declare a V1 of this.
Well, that's fantastic. Distributed applications, just in general, are so complex to write. There's so many decisions to make, and so many. It just takes a lot of experience to doing it well. And I've done my fair share, and now just understanding all that goes into it, and the explosion in our industry, we can either take the path of educating a growing number of software engineers on all the patterns to do it well, or we can just kind of take away the complexity by baking more of that into frameworks that people could just grab via NuGet.
Exactly. So that's exactly the goals of Dapr as a runtime. It's like take all the best practices that we've encountered for distributed systems applications, put them into these individual building blocks that are platform agnostic. They'll run anywhere. They'll hook into any language and any framework because they have this consistent URL syntax of how you can call them. They're open and pluggable, so you can plug in underlying different systems and triggered from different things, and codify those so that it doesn't matter where you come from. It doesn't matter if you're a Python developer or a Go developer or a Rust developer or even a COBOL developer. You can pick up Dapr. You can use these established industry building blocks that have the best practices for them. And everyone can benefit around all of this. And everyone can benefit from seeing that they'll put their energies into a place where we can share this experience together. We can build out and have a way that makes this code portable across different clouds, across different environments. And then and if you want to just use one building block, that's fine. If you want to use 10 of them, that's fine. There's no, you don't have to consume everything. It's not like there's one great big bundle of stuff I have to take. It's just pick and choose whatever you want amongst these. If you just want to do state management, that's fine. If you just, for example, we hooked up Dapr into Azure Functions, and we hooked up the pub sub. So today, Azure Functions, you can't do a publish and subscribe between Azure Functions. If I want to do a publish and subscribe, what you have to do is you have to go off and push it onto a queue, and you have to write all the code yourself.
Yep.
So there's actually in our repo, in one of our samples, it shows an Azure Functions, 2 function applications that get deployed, and we launch Dapr's sidecars next to each one of them. And then by doing a simple publish and subscribe call with a local host, you can do publish and subscribe between 2 Azure Functions. Whereas before you couldn't do that, right, and it required you to write lots of code. So we've now made you as a functions developer more powerful than you were before, because you can do pub sub between these things. And we want to bring stateful functions there as well. So this is the goal.
Awesome. Well, I definitely look forward to digging in and learning more and following it as it continues to progress. So, Mark, thanks for sharing Dapr with us. And I know all the listeners are looking it up as we speak and kind of digging in and looking at the samples. And we'll make sure to include all the URLs and the GitHub repository in the show notes so that they can know exactly where to go.
All right. Well, it's fantastic being here. And my final statement would just be, please come and join the community. We have a Gitter channel you can ask questions on. We have community calls every 2 weeks that you can ask questions on. And we try to be, and we're very active in issues inside, listening to what you want to voice to see as this open source project takes shape.
Awesome. Well, thanks so much, Mark, for coming on the show and spending this time with me.
All right. Thank you.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.